Alright, let's look at theorem 1, which states this. If x equals a is an ordinary point of this differential equation, y double prime plus p of x, y prime plus q of x, y equals 0, then it has two linearly independent solutions of the form y equals summation n goes from 0 to infinity Cn quantity x minus a to the nth power, and whose radius of convergence is at least as large as the distance from the nearest singular point. Right? So let's look at this example. Right? So you have this differential equation and the ordinary point, let's say x equals 4. Right? So first thing I would do is I'm gonna divide through by quantity x squared plus 9, right? So that I can have a 1 as a coefficient of y double prime. So you have a y double prime plus x over x squared plus 9 y prime plus x squared over x squared plus 9 y equal to 0. Right? Then we look for the closest singular point, and we're going to consider the complex value as well. So we can set the denominator. If the denominator equal to 0, then we're in trouble. So let's set the x squared plus 9 equal to 0. Then as you can see that this will give us x equals to plus or minus 3i, right? So this is our singular point. Singular points, right? So the radius of convergence is guaranteed to be as big as, at least as big as, the distance between the ordinary point, in this case x equals 4, to the closest singular point, right? So let's sketch this. So we have, let's sketch the complex plane. So this is the x-axis, which represents the real component, and here is the y-axis, which represents the imaginary component, right? So ordinary point is x equals 4, so it's going to be 1, 2, 3, 4. Right? So we have an ordinary point right here. Right? Then singular points are plus or minus 3i, so it's going to be 1, 2, 3. So here 3i would be up here, or negative 3i is going to be down here. Right, so the distance between these two and these two are the same. I'll just find the distance between this singular point to this ordinary point x equals 4. So this distance is just simply Pythagorean theorem, square root of 3 squared plus square root of 4 squared. So square root of 3 squared is 9. 4 squared is 16, so it's a square root of 25, which is equal to 5, right? So what this theorem 1 guarantees that is that the radius of convergence r, right, must be as big as the distance between these two guys. So it's going to be at least 5, right? So that's what this theorem 1 guarantees. So the radius convergence is at least as big as 5. All right, that's it. I hope that this was clear.